All right. So today is about linear and non-linear functions. The biggest thing that I want you all to realize about linear is the first four letters. They spell line. So a linear function is a line, okay? So a linear function is a function that will make a straight line when it is graphed. An equation that you will always use for a linear function is one that we've already seen, is y equals mx plus b. And what's the m stand for? Slope. And the b is the what? Y-intercept. You can also tell from a table if something is linear when its rate of change is constant. And what's the word constant mean? Always. It doesn't change. So the rate of change is the same over and over and over again, because that rate of change is also called the slope. You may want a calculator if you don't have one. There's some up here in the box. Okay. Shh. All right, it says, in the following examples, we'll use functions to fill out a table of values and create a graph. Look for any patterns among the functions that are linear and those that are not. So the first thing that we're going to do is we're going to fill in the table that they gave us. And we're going to do a little calculator practice here. And I'm going to give you some tips for your calculator. So this first function they give us, we don't know if it's linear or nonlinear yet. So it says x squared plus 1, and it tells me that x is -2, -1, 0, 1, and 2. And they want me to plug those values in for this x, okay? Now, when you plug a negative number in your calculator, does anybody remember what I said that you should do? What are those called, Sherman? Parentheses. So when I go to type -2 in, I'm going to do -2 squared plus 1. So anytime that I'm putting a negative number in my calculator, I'm going to put parentheses around it. And the function says to square the number that you're plugging in. So the squared is right here. And then plus 1. Right above, or right here where it says x squared, above the or below the little arrow next to the 7. Do you have a different calculator? No. Okay. All right, hit enter, and you should have gotten 5. Did you put parentheses around your your 2, your -2? Yeah. Did you put a squared plus 1? All right, and now we're going to plug in -1. So I'm going to do parentheses, -1 squared plus 1. And you should get 2. All right, you all finished filling out the table? So now plug in 0, 1, and 2. All right. So the next one is 0 squared plus 1, which is 0 plus 1, which is 1. And then 1 squared plus 1, that's 1 plus 1, which is 2. And then 2 squared plus 1, that's 4 plus 1, which is 5. Everybody do okay filling out that table? All right, and then when we graph ordered pairs, we graph them as x, comma, y. So this is my x-axis, this is my y-axis. So this first point right here, -2, +5. So x is -2, y is +5. So I'm going to go left to -2 on the x, and then I'm going to go up to +5 on my y. So there's -2, 5. All right, the next one, -1, 2. So I'm going to go left to -1 on my x-axis, and then up 1, 2. And then 0, 1. So that means I go left and right 0, but I go up to 1. And then 1, 2. So right to +1, and then up 1, 2. And 2, 5. So right to +2 on the x, up to +5 on the y. All right, so it says, is the function linear? Why? It's not a straight line. So I'm going to say no. The graph is not a straight line. Yep.
So you know how like we do island, right?
Right.
Will we do the same one as like the rest of
The 7th grade.
Okay.
You're in 7th grade, so you'll do 7th grade.
Hypothetically. We got like 100% on island.
You won't.
I did last year.
You did last year?
No. No, we didn't. Have you ever got 100? Did you guys ever take others?
No, we didn't.
I had I step, but no, I never got 100, but my husband got 100 3 times.
I remember.
Yeah.
What is your husband doing?
He works on machines.
Wow.
All right. I mean, he makes, like, this week he made more money than me. Yeah. All right.
There should be a protest for teachers to get more pay because of how many kids they have to deal with.
All right, let's look at this next one. Oh, okay. All right, so this next one is 1/2 times x. So we don't know if this is a line or not until we get the points and graph them. So I'm going to plug in -4. Now, when you use your calculator for this, 1/2, you will hit 1, ABC, 2. So 1, ABC, and then 2. That'll give you 1/2. Yours, you hit the division line. So 1 divided by 2 will give you 1/2 on yours. And then you're going to hit times, and then you're plugging in a -4 first. So what should I do with the negative? Put it in parentheses. So times -4, enter. Which we would know that half of -4 is -2 anyway. What did it say?
Sync error.
So what did you put for, did you put the ABC button right here? Did it look just like this? Oh, okay, the negative sign, you have to use this. You can't use the minus. Yeah, so you have to use that button for the negative sign. Yeah. All right, now I'm going to do -2. So these you don't really need a calculator on because it's just half. So half times -2 is -1. Yeah, and then half of 0 is 0. Half of 2 is 1. And half of 4 is 2. I just wanted you to practice with a fraction button. Yes, Catherine. Well, did you think that this one had a slope of 1? It doesn't. So that's why right now we're just kind of experimenting, but we'll talk about that in a minute. I don't want you to get in the habit of thinking that until after we get to this next part. But then eventually, yes, you will get in that habit of thinking that. All right, so everybody take your graph and graph your points if you haven't already. Franklin, graph your points. Okay, is this function linear? Yes, and it's because the graph is a straight line.
Does this one matter if it goes through the origin or not?
Nope. It just has to do if it's a straight line or not. So some people will say, well, Miss Wilson, how do you connect the dots on problems like this? Okay, like on this first one, how would you connect the dots? And the way that you would connect the dots is the way that you read a sentence from left to right. So you would start up here because this is the farthest left point, and then you would just follow that point all the way to the right. So this is called a parabola. It's a parabola. It's a U-shaped graph. How do you solve that? Parabola. All right, this one, I would just connect it from left to right. So it just makes a straight line. Okay, between these two functions, so what I'm talking about, what I'm talking about is this function right here and this function right here. What are some differences that you notice about the two functions, Ryan? We didn't have to find the slope to graph this one. I'm just talking about if I just gave you those two functions without making you do anything with them, what could you tell me is different about them? Nope. Trevor? Well, we don't know that. We don't know that just by looking at it. Or are you talking about because it's just y equals x? Okay, like the y equals mx one. Okay, that's not what I'm looking for yet, though, because that's not it. Kate?
This one
Hello. No. Bye. Okay, Kate, go ahead. Sorry.
this one's a function is linear, and this one is not.
But how do you know that? Like, if I know, but if you did not have the table and you did not have the graph, I just gave you the two pink things. Okay, Sherman? Yes. Okay, the first function has x squared and the second does not. Output is only x. So the first function has x to the second power. The second function only has x. And that's the big difference between the two. Yes, I know that this one has like a plus number, so that's the y-intercept. I get that. And this one does not have a y-intercept, but it does have a y-intercept. It's just at 0. But that's the main difference. Yes, Taryn? Parabolas are symmetrical. So like if you were to fold the graph on this line right here, these points would match up perfectly. And that's an Algebra 1 skill. Yes, Preston? The number that you all would think is the slope here is not the slope. It's the wideness or skinniness of the graph. So it doesn't work like slope. It just tells you if the graph is going to be skinnier or wider. But that's not even now. Like that's going to be something way different. All right. Okay, well, I'm not, the only thing that I want you to understand, guys, the only thing I want you to understand is that this one has an x squared and this one just has an x. Do you understand that? Yeah. That this one has a squared on the x and this one does not. That's the only thing that I want you to understand from that. Okay. All right. We're going to go to the back. All right. So the first one, y equals x to the third. So on your calculators, you all, besides probably Brecken, do not have an exponent for 3. So what you would do is we're going to take -2 and we're going to cube it to the third power. So on your calculator, parenthesis, -2, close parentheses. So let's get that on there. And then you're going to hit the caret button, which is this arrow button. It's right, it's up and left of the 7. Yours says YX. So you're going to hit this button, 3, and enter. So look for that button. Anybody else? Anybody else have the calculator? Oh, okay. All right. All right, so -8. Guys. All right, now I'm going to put 1 in there. So -1 cubed. Oops. And I get -1. And then you don't have to put an x, like parentheses around the positive number. So you can just hit 0 cubed, which we know is 0. 1 to the third power, which is 1. And 2 to the third power, which is 8. All right, so if you look at the y-axis, what is the y-axis counting by? 2. So when you go to graph this, you need to make sure you're paying attention. So this is the first point, -2, -8. So left to -2, but down to -8, counting by 2. So 2, 4, 6, 8. So right there. -1, -1. Where am I going to go to -1 on my y-axis? In between 0 and -2. So halfway between. So like right there. And then 0, 0. 1, 1. But I only go halfway up because it's counting by 2s. And then 2, 8. Okay, based off your graph, is this function linear? No. And then we say the graph is not a line. No, it's not.
It's a line that's not straight.
It has to be I guess we should say a straight line. Sorry. A straight line. If you want to connect it, if that makes you feel better, this is a cubic function. So you start down here because this is the farthest left point, and then you just follow that up. All right, I want you all to do number 4 by yourself. So I'll give you a minute to do that one. Okay, because you're using a minus sign, you have to use the negative sign down there. That's why. Guys, shh. All right. So check your numbers up here. Make sure they're the same. Okay. So then -4, and my y-axis is counting by 2s again. So -4, -4. -2, -1. Shh. 0, 2, 2, 5, and 4, 8. So is this one linear? Yes, because it's a straight line. All right, this last one here, the last one that we're doing a graph on. What operation is this? Division. So this is 12 divided by x. So you're just going to take 12 and you're going to divide it by all these numbers. Okay, so we'll just do this one out loud. So what's 12 divided by 1? Okay. What's 12 divided by 2? 12 divided by 3. 12 divided by 4. 12 divided by 6. 2. All right, and if we look at it, the y-axis is counting by 2s. So 1, and then I'm going to go up to 12. 2, and then up to 6. 3, and then 4. 4, and then 3. And then 6 and 2. And no, this one is not a straight line. This is an exponential function, which will not come till probably algebra 2. Yeah. It's like a line that has a slight curve to it. A very slight curve. Yeah. Yes, Taryn. Yes. So the whole half of the last third, 9 weeks, and then the whole fourth 9 weeks, you all will be factoring. And then that's one of the skills that you pretty much do every single week in Algebra 2. It goes with everything. Okay, real quick. Shh. Okay, the biggest thing that I want you all to notice, okay, because I don't even care about this. The biggest thing that I want you to notice is that all linear equations have no exponents on the x. Now, somebody might be thinking, well, Miss Wilson, number 5 didn't have an exponent on the x. It was 12 over x. So why wasn't that one linear? And Preston's going to tell us why. This is actually x to the -1. So if I was to move this up, that's actually 12x to the -1. Because remember when we were working on exponent rules, negative exponents went to the other side of the fraction. So that's why it was on the bottom, because it had a negative exponent originally. Okay, so all linear equations will have no exponents on the x, and the x will be on the top. So like number 4, look, it was y equals mx plus b. Like number 2, which was just y equals mx. Okay? And then if you look at the tables, the only difference that you notice about the tables is that linear lines are constant. So I'll just put on here if you want to put something in here. Linear are constant. Others are not. All right, does anybody have any questions? Maybe something they didn't understand or any of that fun stuff? Yes, Taryn? I'll tell you in a minute. Okay, let me stop my video here.